Hey, do you see this problem? This problem basically says do all of the things ever that you could ever be asked of by Reed for this conic section. So we want to, first off, let's factor it and get it into our factored form so we can identify the center. How are we going to do that? Well, I'm going to add 4y squared to both sides. I'm going to add that 36x to that side as well, and I'm going to move that 36 over. So I'm going to deal with 9x squared plus 36x minus, plus, just kidding, 4y squared because I'm adding it over, minus 24y equals negative 36. And now let's factor out the coefficient on each individual squared term. So I need to factor out the 9 from my x stuff, so it's going to leave x squared plus 36 divided by 9 is 4x. Let's go ahead and complete this square right now. Completing the square means I take half of that 4, so 2, and I square it, so 4 right there. And then that needs to be plus 4 factored out of my y terms, y squared minus, what's 24 divided by 4? Well, it is 6y. And again, let's complete the square. So half of that middle coefficient squared, half of 6 is 3, squared is 9. And that will equal that negative 36, but I need to balance my equation. I added this 4 times 9, so I need to add 4 times 9 right there, and I added another 4 times 9 actually, and so I need to add another 4 times 9 right there. I don't know why I put a parenthesis there. There you have it. So what does that give us? Well, look, 4 times 9 is actually 36, and so I have a negative 36 and a positive 36, so that's gone, so I'm just left with 36, which is kind of cool. And now I can divide everything by 36. So 9 over 36, well, how about you think of 36 divided by 9? 36 divided by 9 is 4, which is telling me that this completed square right here, x plus 2 quantity square, needs to have a denominator of 36 divided by 9 is 4, so I'm going to write that as 2 squared, plus 36 divided by 4, well, that gives you 9, and so that completed square is a y minus 3 quantity squared divided by 9, or 3 squared. And that equals 36 over 36, which is 1. And so I have the equation in rectangular form. Well, let's go ahead and write it in, parametric form as well. So let's look at our x term first. X equals the denominator, the square root of the denominator, so x equals 2, notice that 2 just went right there, 2 times cosine of theta. Since it's plus 2 up there, that's telling me that my h value is actually minus 2, so I need to have minus 2 right there. For our y equation, again, notice that the 3 squared is the denominator, so that's going to give me a coefficient of 3 times the sine of theta. Since it's minus 3 up top, that means my k value is a positive 3. And I get my parametric equations right there. What can I identify? Well, I can identify that this ellipse is oriented vertically, since the denominator of y is bigger, which tells me that a is 3, b is 2, and I can find c by taking the square root. Well, let's write it down. What do we know? We know that a squared is 9 equals b squared is 4 plus c squared. So 9 minus 4 is 5, gives us c squared, so c is the square root of 5. So I've got a, b, and c. What can I now identify? Well, let's identify the vertex real quick. Lied. Let's identify the center real quick. Center's going to have an x value of negative 2, a y value of positive 3. Let's identify from that the foci. Well, the foci are going to occur, since it's vertical, the x value is going to be the same, negative 2. The y value of the center is going to change by adding or subtracting c, which is the square root of 5. So there's your foci. And finally, vertices, in the same way, x value is the same. From 3, we need to add and subtract our a value, 3. So let's write that as vertex 1 is negative 2, comma 3 plus 3 is 6, And vertex 2 is x value negative 2, comma 3 minus 3 is 0. So I've got my center, my foci, my vertices. What else do I need to know? Well, I need to find its eccentricity. I need to sketch its graph, but I got rectangular form, and I got parametric form. So that should be everything, and then just graphing it. So remember eccentricity. Whoa. Eccentricity is C divided by A. And so our eccentricity equals the square root of 5 divided by 3, which is actually the same exact eccentricity as that last problem, which is kind of interesting. I wonder why that is, looking at that and looking at those pieces right there. And so all we need to do now is graph this ellipse. So again, where is our x value? I actually like using a parametric equation to help me graph an ellipse, just because I like the way the pieces come together. I know that that minus 2 is telling me the x value of the center, so that needs to be a minus 2 right there. That positive 3 is telling me the y value of the center, so a positive 3 and a negative 2 for x. There we have our center. That a, that 2 with the x, that 2 cosine theta is saying, hey dude, go to the right 2, and hey dude, go to the left 2, because I'm hanging out with x. And then let's do the same thing there. That 3 in front of that sine theta on the y term is saying, yo, what up? Go up 3, 1, 2, 3, and go down 3 from the center to get your vertices right there. And then we can boop, 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 draw in our little egg. Where my foci at? Well, my foci are going to be the square root of 5 up and down from the center. And in the last problem, we determined that 2 times the square root of 5 was like 4.5. So that means that the square root of 5 must be about 2 1/4. So let's go up 2 1/4 to plop and down 2 1/4 to plop there. And now we have everything written out correctly, and there you have it all in a nutshell.